In early 2024, NVIDIA's market valuation briefly surpassed the entire gross domestic product of the United Kingdom, crossing the $4 trillion mark. They occupy a singular role in the modern economy, supplying the physical machinery required to train and run the models powering the global AI revolution. It is a jarring contrast to 30 years ago, when this infrastructure empire was a nearly bankrupt startup struggling to sell circuit boards to video game players. In 1993, 3 engineers founded NVIDIA in a Fremont Denny's with $40,000 in the bank. Their goal was to bring 3D graphics, then a tool for high-end workstations, to the average consumer PC. CEO Jensen Huang was betting on a specific outcome, that visual computing would eventually dictate how humans and machines interact. That bet almost ended the company in 1995. Their first chip, the NV1, used a quadrilateral rendering approach that the rest of the industry abandoned in favor of triangle-based standards. Developers ignored the chip, and the NV1 was a commercial disaster. By 1996, with only 1 month of payroll left and half the staff laid off, the company was saved by a $5 million investment from an executive at Sega who saw potential in NVIDIA's engineers. They used that capital for one final high-risk production run. The resulting Riva 128 chip sold 1 million units in months, establishing a survival DNA that persists today. Admit failure immediately, pivot to what platforms actually want, and bet everything when the odds are right. In 2006, Huang realized graphics chips were perfect for more than pixels. A GPU is thousands of tiny cores crunching data simultaneously, in parallel. To unlock this, NVIDIA launched CUDA, a software platform allowing programmers to use GPUs for general-purpose supercomputing. The market response was overwhelmingly negative. Analysts saw NVIDIA spending billions on a tool for an obscure corner of academic science. By 2008, the company's stock had plummeted 70%. Huang refused to retreat. He wanted to take the computing power once reserved for national labs and put it into the hands of any researcher with a few GPUs. He was building a market that didn't exist yet. That market finally appeared in 2012 at the ImageNet competition. Geoffrey Hinton's lab decided to experiment with a deep neural network, a concept that was then unfashionable in the field of AI. Using 2 consumer NVIDIA graphics cards and the CUDA platform, they built AlexNet. The model crushed the competition, slashing error rates and proving consumer GPUs were perfect for deep learning. Huang recognized the significance immediately. He declared NVIDIA was no longer a graphics company, pivoting the entire organization toward deep learning hardware and software. A decade of market skepticism was suddenly validated. The hardware they built for gamers turned out to be the foundational tool for the artificial intelligence revolution. The release of ChatGPT in late 2022 turned this research trend into a global event. Generative AI became a visible tool for billions almost overnight. This created a surge in demand that only NVIDIA was prepared to meet. They had spent the previous decade developing AI-specific architectures like Volta and Ampere, which formed the backbone of the initial GPT training clusters. This readiness transformed the company. They moved beyond being a simple chip vendor and became the primary infrastructure provider for every major player in the AI field. This raises an obvious question. Why can't competitors like Google, Amazon, or AMD simply build a faster chip and break this monopoly? The answer is CUDA. NVIDIA built an interlocking wall of software supporting every major AI framework. Switching chips means developers must rewrite millions of lines of code and abandon a decade of tools. Leaving the ecosystem costs more than the hardware itself. CUDA is the company's actual defensive moat. The high-end chips are simply the mechanism NVIDIA uses to monetize that software dominance. NVIDIA is now expanding that moat, moving from standalone chips to end-to-end AI factories. Their upcoming Blackwell and Rubin architectures are designed to function as entire computing systems rather than individual components. Powerful forces are testing this dominance. Cloud providers are developing custom silicon, geopolitical controls are limiting global sales, and energy consumption draws intense scrutiny. The company's modern campus reflects its current scale, coordinating the infrastructure for everything from self-driving cars to digital twins of the entire planet. NVIDIA's position at the top depends on a long-standing pattern, seeing the next revolution early, taking the financial pain while others are skeptical, and building the platform that everyone else will eventually need.